Let's work through this geometry problem carefully, because the key idea is not to chase angles or try to calculate the interior perpendicular lengths. Instead, there is a beautiful theorem that lets us use only the pieces of the three sides. We have a triangle, and inside it, there is a point from which perpendicular segments are drawn to all three sides. The side pieces are given in terms of x. Our goal is to find x first, and then use it to determine the perimeter of the triangle. Let's begin by identifying the 6 pieces around the triangle. On the first side, the 2 pieces are 5 and x plus 4. On the second side, the 2 pieces are 6 plus 1. On the third side, the 2 pieces are 9 and x. Now, notice that the perpendicular construction inside the triangle gives us exactly the setting where Carnot's theorem for perpendiculars can be used. The important idea behind this theorem is that for a point inside a triangle with perpendiculars drawn to the 3 sides, the sums of the squares of the alternating side segments are equal. So rather than finding any angles or the actual perpendicular distances, we can immediately create an equation using the 6 side segments. The 3 alternating pieces on one side of the equation are 5, 6, and 9, while the other 3 are x, x plus 1, and x plus 4. Therefore, our equation is 5 squared plus 6 squared plus 9 squared equals x squared plus the quantity x plus 1 whole squared plus the quantity x plus 4 whole squared. Now let's slow down and calculate each part carefully. 5 squared is 25, 6 squared is 36, and 9 squared is 81. So the entire left-hand side becomes 25 plus 36 plus 81, which equals 142. On the right-hand side, we have x squared plus the quantity x plus 1 whole squared plus the quantity x plus 4 whole squared. Now we need to expand those 2 squared expressions. Remember the identity, the quantity a plus b whole squared equals a squared plus 2ab plus b squared. So the quantity x plus 1 whole squared becomes x squared plus 2x plus 1. Similarly, the quantity x plus 4 whole squared becomes x squared plus 8x plus 16. Therefore, our equation becomes 142 equals x squared plus the quantity x squared plus 2, x plus 1, plus the quantity x squared plus 8, x plus 16. Now let's combine like terms. We have 3 x squared terms because there is 1 x squared from each of the 3 expressions. For the x terms, we have 2x plus 8x, giving 10x. And for the constants, we have 1 plus 16, giving 17. So we get 142 equals 3x squared plus 10x plus 17. Now we want to solve for x, so let's move everything to one side. Subtract 142 from both sides. This gives 0 equals 3x squared plus 10x plus 17 minus 142. 17 minus 142 is negative 125. So our quadratic equation is 3x squared plus 10x minus 125 equals 0. At this point, we have a standard quadratic equation, and we can solve it using the quadratic formula. Remember, for an equation of the form ax squared plus bx plus c equals 0, the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4. AC, all divided by 2a. Here, a is 3, b is 10, and c is negative 125. So, substituting these values gives x equals negative 10 plus or minus the square root of 10 squared minus 4, multiplied by 3, multiplied by negative 125, all divided by 6. Let's simplify the expression inside the square root carefully. 10 squared is 100. The product of 4, 3, and negative 125 is negative 1,500. Because we are subtracting that negative quantity, it becomes addition. So the expression under the square root is 100 plus 1,500, which equals 1,600. Therefore, x equals negative 10 plus or minus the square root of 1,600 divided by 6. The square root of 1,600 is 40, so we now have x equals negative 10 plus or minus 40 divided by 6. This gives us two possible values for x. Using the plus sign, x equals negative 10 plus 40 divided by 6. That is 30 divided by 6, which equals 5. Using the minus sign, x equals negative 10 minus 40 divided by 6, which gives negative 50 divided by 6, or negative 25 over 3. Now, we have to make an important geometry observation. X represents a length, and a physical length cannot be negative. Therefore, we reject negative 25 over 3 and keep the positive solution. So, we have x equals 5. If you're following along so far, this is a good point to pause and check the quadratic calculation, because getting x equals 5 is what allows everything else to fall into place. Now let's use x equals 5 to find the actual lengths of the three sides of the triangle. Start with the first side. Its two pieces are 5 and x plus 4. Since x equals 5, x plus 4 equals 5 plus 4, which is 9. Therefore, the entire first side is 5 plus 9, giving 14 units. Now move to the second side. Its two pieces are 6 and x plus 1. Substituting x equals 5, we get 5 plus 1, which is 6, so the entire second side is 6 plus 6, giving 12 units. Finally, look at the third side. Its two pieces are 9 and x. Since x equals 5, that side is 9 plus 5, which gives 14 units. So the three side lengths of our triangle are 14, 12, and 14. Notice what happened here. We did not need to find the lengths of the perpendicular segments inside the triangle at all. Carnot's theorem allowed us to determine x directly from the alternating side pieces. And once x was known, the perimeter became a straightforward calculation. The perimeter of a triangle is simply the sum of its three side lengths. So we have perimeter equals 14 plus 12 plus 14. Adding 14 and 12 gives 26, and adding the remaining 14 gives 40. Therefore, the perimeter of the triangle is 40 units. That is our final answer. If this kind of geometry solution is useful to you, take a moment to like the video, subscribe for more step-by-step mathematics, and comment your answer below before checking the final result. The main lesson here is to recognize the structure of the diagram. When an interior point has perpendiculars to all three sides, Carnot's theorem can turn a complicated-looking geometry diagram into a clean algebraic equation. We used the alternating squared side segments, expanded the quadratic expressions carefully, solved the resulting quadratic equation, rejected the negative value because x represents a length, substituted x equals 5 into each side, and finally added the three side lengths to obtain a perimeter of 40 units.